Hello, this is Dr. Egan. This is our first recorded presentation for Design 1. It's going to cover design process, which is a nice overview of the steps you're going to take throughout this course. The recorded lectures are abridged in the number of slides compared to the PDFs posted on Blackboard. So just recognize here that I'm focusing a bit more on talking about what's more relevant to your projects, and we're also going to be discussing this in class as well, especially before we do group work on the projects. This lecture comes from the Dieter and Schmidt Engineering Design book. This is a popular book for undergraduate senior design courses. Earlier editions may be freely available online, the digital version, so there's no need to purchase this textbook for the course, but it is a handy textbook to, look at in your future design and go back to because it really covers a little bit of every piece of knowledge you would want to consider when designing. And so the slides in this presentation are also modified based on the textbook. And there's a lot of definitions of design, especially depending on who you're talking to in engineering or outside of engineering. So we're going to have a working definition for this class based on the Dieter and Schmidt textbook. It's to synthesize new or to arrange existing things in a new way to satisfy a recognized need of society. So the important things here is that you're creating something new that didn't exist before. And so this is generally some kind of mechanical system for our class, and that you're also doing this in relation to providing value or solving a problem that has some importance beyond the device itself. One of the reasons that the engineering design process is important is that design decisions early in the project typically cost very little in consideration to actually producing the product, but have a major effect on the cost of the product and also what you're going to output as far as value by the end. So you can't compensate in manufacturing for flaws in your design that you introduce in the design phase. And the design process should be conducted so that you're creating cost competitive products in the shortest time possible. So by exploring more options early in the design process and designing on paper an optimal solution for your problem, that's going to save much more time compared to just going with your first idea, building it, seeing it's deficient in some way, and then having to go back to the beginning again. And one of the ways that design helps us is by following a rigorous method. So design can be very flexible or very rigorous depending on how you're approaching it. So we all learn about the scientific method where we take existing knowledge, we conduct a hypothesis, we analyze through an experiment, and then we determine if the hypothesis is supported or not, and our body of knowledge increases. So design can follow a similar process, but you're looking at the state of the art of all technologies that exist currently, identifying some need, seeing whether the state of the art can satisfy that need, or creating new ideas and conceptualization that could improve upon the state of the art for your problem. Then after you come up with these ideas, you determine their feasibility, you actually build it, and then you get some kind of feedback and acceptance in the market or through testing. And this is an iterative process as well, where once you create one solution for your design, you could see going through the process again and improving it. And one of the most important parts of design is coming up with a problem definition that really clearly communicates what you're working on. So this is a common cartoon schematic that's shown where you can see these different communication errors that might happen in your project. So the project sponsor proposes a swing, but then you can see these different interpretations where the project request, they built it slightly differently. The senior designer didn't quite understand how it works, so you don't even have a swing at this point. Manufacturing couldn't follow the directions drawn by the engineer, or the user, installed it wrong as well. And then since you took the direction from the project sponsor in the first place, you should have talked to the user and seen that they actually wanted a tire swing. So this is why we go through customer discovery and problem definition early in design, because you want to make sure what you're building and you're putting your time into is actually the end result that's going to make a positive difference and provide value to your user or your client. Another thing about the design process is you have much more freedom early in a project before you're committing costs and reaching manufacturing constraints. But there's a paradox because you're making decisions with less information early in the project, whereas later in the project you gain more knowledge about the design problem. So if you went back to the drawing board, you would ultimately come up with a better idea. So you're always needing to balance the idea of gaining more knowledge about the design problem, but also committing resources reasonably as you're moving forward in the project. So because of this, flexible designs are good to consider early in the process because that allows you to zero in on better design decisions later on as you learn more about the user or learn more through product testing and prototyping. So there's three major phases to design that we'll be covering. The conceptual, which is coming up with your problem definition and design idea. Embodiment, where you engineer and configure it. And then detailed design, where you're putting together the drawings for the machine shop, putting together the budget, and optimizing. And so you'll be following this throughout the semester for your projects. So conceptual design is where we're going to be spending a big portion of the class, approximately the next 7 weeks. So you can think of these each as 2-week modules that finish with your presentation. So right now we're on define problem. And a big part of this is a problem statement and looking at relevant products on the market today. Gather information is where you start doing patent searches and getting customer information. Concept generation is where creativity comes into play and you brainstorm different ways of solving your problem. And then evaluation of concepts is based on all of this, looking at different options to decide going forward what you're going to build and what you're going to focus on refining and constructing for design 2. Embodiment design is where you take your idea and you start picking out components and dimensioning it and configuring how everything's going to fit together. And detailed design is where you finalize the parts list, the budget, and you have drawings that are ready to go to production. So by the end of Design 1 course, we're planning to have a detailed schematic of your entire product with knowing exactly how all the parts are going to go in your system, how it's going to be functioning, and then also in the preliminary design phase, you're going to need to do some kind of mechanical analysis on your system. So the most important thing in the course is that you're creating a product that solves a problem and does it in a mechanically efficient way. But as you're designing, you need to be aware of other influences rather than just the design itself that's going to affect your decisions. And these come from different design regulations. So one place is to think of the materials life cycle. When you're building your product, you need to think of where you're going to buy materials from, what types of materials you're going to use. This is going to affect the costs and also sustainability and maintenance of your parts in your system. And then also you need to think of the end of life. So are you going to recycle your system by the end, or is it going to be disposed of, or is it going to be reused in some manner? Regulatory and societal issues come from code of ethics that all engineers need to adhere to. And so we need to protect public health and safety in any product. We can't cause harm to society. And so some examples of standards and codes, especially for us, is going to be ASME, so American Society of Mechanical Engineers, and then things like American Society for Testing and Materials to make sure that your claims of, for instance, you're going to support a certain amount of weight with your design, that you can back it up on paper before it goes into market. Another thing that's going to affect your design decisions is that technology is always advancing. So for instance, CAD and finite element analysis are things we could conduct today that couldn't be conducted 50 years ago. So the standards and how well you need to analyze your design is going to change based on the technology, and also the ways that you optimize your design is going to be based on technologies available. And this can also affect material selection as well as new materials hit the market. Design reviews are also commonly conducted during the design process to make sure that you're hitting specifications at each phase throughout a project. And so that's why we're having the regular presentations throughout the course, because they make up design review practice, and then also why you're going to have to do a report on your design at the end of the course, which is going to be basically a justification or proposal that your engineer design is justified and should be supported and funded to go into design 2. And so things that you want to consider in product reviews, design reviews, is the performance requirements, the environment you're operating it on, the product's life, its quality, reliability, cost, and then also a lot of other design requirements that are going to be specific to your team. And another thing that comes up in design decisions is government's role. So this can be different taxes or regulations. So especially when you think about the COVID cases right now, that can restrict design decisions, and the economy can restrict what the market is willing to buy. And so you need to consider how the government's going to change policies, and also what your funding is for your design, whether you can move forward with research and development or grants, and also what technologies are available. So now we're going to focus on problem definition, and this is what you're going to need to know for your presentation. For all of your design groups, you need to clearly state what problem you're trying to solve and the societal need, that it's going to fit and help. So problem definition makes up the first phase of conceptual design. And the problem definition, the process to go about it, is product development begins by determining what needs a product must fulfill. The problem definition is the most important of these steps to determine the need and to continue with product development. You need to thoroughly understand the problem in order to come up with the correct solution to solve that problem. And so you need to recognize a current issue that is not solved and the need that your design is going to provide when you solve that issue. And that could be, let's say, for a disabled person who has difficulty walking, they need something that's going to help them move from one place to another. So if you created a wheelchair, that would be solving that need. And it extends to society because many people are affected with this same issue. So your mechanical design, is reaching a broader audience and a greater good. So in order to come up with your background research, your problem definition, you need to conduct background research, and this can be done through a number of scholarly sources and then also different news sites. And you should always, with any research you do, use multiple sources for any claims that you're making. And you need to look at, who does your problem affect? Who in society is going to benefit when you solve this problem? How many people, what this specific person is. The background research, you can use, like I said, websites or academic journal papers. You could use patents. You can use expert research, talking to experts in the field. And you need to consider your end customer or client and what research you could do to understand them better. Because if you understand your client better, you're going to be able to deliver a better product to them. And so when you're coming up with a problem statement, the definition, you need to state the problem and the need. And you need to, at this point, be careful not to assume a design or device that solves this problem. So it's very easy to get locked into, well, I'm going to build a wheelchair to solve this problem to help them walk, but maybe that person crutches would have been better. So if you lock yourself into, I'm going to design a better wheelchair to help people in mobility issues, then you're locking yourself into a solution that might not be the best. So some example problem statements: 3D food printing is an emerging technology. There is a need for more efficient processing of biomaterials to facilitate printing. Cerebral palsy inhibits the movement and everyday functioning of many children, so there is a need for aiding moving efficiency and reducing frustrations in day-to-day activities. And I think by really narrowing and focusing your problem statement to one sentence that states the problem and the need, is going to help your group a lot moving forward to be able to always go back to your design decisions. Are you really solving your problem better by making this decision, or are you going on some kind of tangent that isn't quite as important to your core problem? So this concludes the presentation, and I'm happy to answer any questions and also discuss more during class time or office hours.